In this video, we are walking through an example of how to find the binding energy of a curium-247 nucleus. So I wrote down curium-247, and then I looked up on the periodic table and found out that the atomic number of curium is 96. So that tells me that I'm going to have 96 protons inside the nucleus, and 247 minus 96 would give me 151 neutrons. So looking at the mass of a proton and neutron in atomic mass units, those are those values there. So I'm going to take my calculator and I'm going to multiply 96 times 1.007825, and then I'm going to keep all that on my screen, and now I'm going to add 151 times 1.008665, and this would be the mass of the particles that I would need to make the nucleus. And so the mass is going to be 249 and this is where I'm going to keep all of my decimal places that my calculator is showing me. So this mass is in atomic mass units. By the way, on some calculators, they don't have AMUs in the calculator, they only have a U. So if you're under your mass menu, a U stands for atomic mass units. So it's given to us in the problem, or we look up in an appendix of a book or on the internet, that if we actually took these particles and we squished them together into a nucleus, meaning that we have all 96 protons in here and we have all 151 neutrons in here, the mass of the nucleus is, in this case it's given to you on the worksheet, 247.0703447 AMUs. So you can always do a check that the particles themselves should always have a greater mass than the nucleus. So I do have some missing mass, so I'm going to subtract, and the missing mass is called the mass defect. So I'm going to write that down. Mass defect. And I'm now going to take 247, oops, I take that back, I'm going to clear that. I'm going to take the answer that I got and I'm going to subtract 247.070347 and find out that my missing mass is, my mass defect is 1.98926 AMUs. Again, the point here is that if we're looking for missing mass, we want to make sure we account for all of it. That's why I'm keeping all of those decimal places. So the next thing I'm going to do is I then am going to take this value in AMUs and I'm going to convert it into kilograms. So that's why I'm using this calculator, because the conversion menu is a little bit easier to use. So I'm going to go into my mass menu, and I have AMUs, and I want to convert that into kilograms. So that is 3.03 to the negative 27. 3.03 times 10 to the negative 27 kilograms. So we're not missing too much mass. So the next thing that we're going to do then is we're going to figure out the binding energy by using